What's your name?
I am the founder and the faculty of the Khan Academy.
What is it that you do?
I started making YouTube videos.
Wow, I can't wait to see it.
Factor t squared plus 8t plus 15. So let's just think about what happens if we multiply two binomials t plus a times t plus b. And I'm using t here because t is the variable in the polynomial that we need to factor. So if you multiply this out, applying the distributive property twice, or using FOIL, you get t times t, which is t squared, plus t times b, which is bt, plus a times t, which is at, plus a times b, which is ab. We essentially multiplied every term here by every term over there. And then we have two terms, two t terms, I guess you could call them. This is bt plus at. So we could combine those, and we get t squared plus a plus bt. I could have written this as b plus at as well, plus ab. Now, if we compare this to this right over here, we see that we have a similar pattern. Our coefficient on the second degree term is 1. Our coefficient on the second degree term here is 1. We didn't have to write it. Then a plus b is the coefficient on t. So 8, right over here, this 8 could be a plus b. And then finally, our constant term, ab, that could be 15. That could be 15. So if we wanted to factor this out, we just have to find an a and a b where their product is 15 and their sum is 8 in general. In general, if you've ever seen, I'll write it in kind of the more traditional with an x variable. If you see anything of the form x squared plus bx plus c, the coefficient here is 1. Then you just have to find two numbers whose sum is equal to this thing right here and whose product is equal to that thing right there. Whose sum is equal to 8 and whose product is equal to 15. So what are two numbers that add up to 8 whose products are 15? So if you just factor 15, it could be 1 and 15. Those don't add up to 8 in any way. 3 and 5, those do add up to 8. So a and b could be 3 and 5. So a and b, this could be 3 times 5, and then 8 is 3 plus 5. Now we could just go straight and factor this and say, hey, this is t plus 3 times t plus 5, since we already figured out what a and b are. But what I want to do is kind of factor this by grouping. So I'm essentially going to go in reverse steps from what I just showed you. So this polynomial right here, I'm going to write it as t squared plus, instead of writing 8t, I'm going to write it as the sum of at plus bt, or the sum of 3t plus 5t. So plus 3t plus 5t. So I'm essentially, I've started here, and then I'm going to this step where I break up that middle term into the coefficients that add up to the 8, and then finally plus 50. And now I can factor it by grouping. These two guys right over here have a common factor of t, and then these two guys over here have a common factor of 5. So let's factor out the t in this first expression right over here, or this part of the expression. So it's t times t plus 3 plus, and then over here, if you factor out a 5, you get a 5 times t plus 3. 5t divided by 5 is t. 15 divided by 5 is 3. And now you can factor out a t plus 3. You have a t plus 3, and you multiply times both of these terms. So let's factor that out. So it becomes t plus 3 times t plus 5 times, we'll write the plus a little bit neater, times t plus 5. And we are done. We actually didn't even have to do this grouping step, although hopefully you see that it does work. We could have just said, look, from this pattern over here, I have two numbers that add up to 8, and their product is 15. So this must be t plus 3 times t plus 5, or t plus 5 times t plus 3. Either way.
The issue that I had was, you got to know your audience. So why are you saying t plus a times t plus b and doing this abstract proof when you could start with just numbers? And in that way, the students who are real weak, who are coming to your place for videos, I think they'll be able to understand it more. They get turned off by the t plus a, t plus b. And that was why I had to buzz you. Well, I think that you're a very nice man, but the problem I had is you have only this example with all positive numbers, but many examples have negative numbers, and without negatives, I think they may only be able to do ones with positives, and that's a weakness of this lesson. This is the only time that they're exposed in your course to this very important topic, and most examples have negative numbers, so that's why I had to buzz you.
Now listen, Sal. You seem like a nice enough guy. I got nothing against you personally, but my issue was, why factor by grouping? Nobody does it that way, factor by grouping. You told them they figured out what A and B were, they're done. What is this factor by grouping thing? That's just going to confuse people, and no real teacher does it that way. So once you did that, to me, that was it. Now, I just don't think it's $1 million act, okay? But you do seem like a nice guy, so thanks a lot for playing, and good luck to you.
It's a no for me.